B1 as well. So we now need to determine the size of DAB. So this is D, that's AB. So it's DAB. So that's the wrong diagram. I think it's the wrong diagram. Is this the correct diagram? The diagram is correct now. All right. So we're supposed to find DAB. Can you stop talking now and pay attention? So DAB is this angle. Now, based on the information we have from the previous question, right? D1 is 30. So this is 30. And C2 is 60 degrees. Okay. So C2 is 90, sorry. Okay, it's 90. C2 is 90. And we also calculated B1 and we got it as 60. So B1, which is this one here, is equal to 60 degrees. All right. Now, I'm sure you can see that to find DAB, it's very easy. You identify your cyclic quad. Okay? Your cyclic quad is going to be A, B, C, D. So these 4 points are at the circumference of the circle. Therefore, A, B, C, D is a cyclic quad. And we are also told here in the question. Okay? Since A, B, C, D is a cyclic quad, it means angle A plus angle C plus angle C2 must give us what? 180. Because the opposite angles of a cyclic quad are supplementary. So, doing 8.1.4 is very, very simple. So 8.1.4, we say angle A plus C2, they add up to 180. Your reason is opposite angles of cyclic quad. Please, there is no need to write supplementary after that. Okay? Use the acceptable reasons that I gave you. Opposite angles of cyclic quad. If you add supplementary, it's fine, but it's not necessary. Yes? No. You can't. All right. Can you pay attention there? Pay attention. Sometimes you just have to close your mouth and pay attention. All right. She's bringing up something very important. Please, when you are answering geometry questions, don't make assumptions. Okay? Of course, BD looks like it's a diameter. But are you told that it's a diameter? No. So don't make that assumption. You might have to prove that it is a diameter first. If you prove that it's a diameter, then when you answer 8.1.4, you can end up saying that BD is a diameter. But we are not told, so you might have to prove that. Okay? But for this question, if you prove that BD is a diameter, you'll be answering question 8.2 before you start answering it. Okay? So that is the way which I would suggest you go. Okay?
But if you say that
C2, yeah, that's why I'm saying you'll be answering 8.2.
but if you say it's proven, you know,
Well, if you decide to do it that way, then it means you'll be answering 8.2 twice. Which, okay, can be acceptable. Okay, because the whole idea is actually problem solving here. Okay, but I would prefer that. Yes? Yeah, it's acceptable because if you have no other way, then you might have to prove that BD is a what? It's a diameter. Okay, so angle A will be equal to 180 minus 90 degrees, and you get 90 degrees. the way you're walking. Okay, let's carry on. I'm using a metaphor. Okay, who is your English teacher?
Pardon?
Who is your English?
No, I knew you were using a metaphor, but like.
All right. 8.2. Suppose you know that is the first lesson, right? You are in a meeting.
Yeah.
The meeting gets finished. You rush to your what?
We were just trying to.
Okay, 8.2. Right. Is there anybody who has got any question with 8.1.4? Is there anybody who has got a question with 8.1.4? Okay, if you don't have a question, then let's move on to 8.2. Now, 8.2 says, is BD a diameter of a circle? Right, the answer is a yes. Right? The answer is a yes. Right? Now, that first mark may be very easy to get. The second mark, you have to give a reason. Your reason, you can write here, converse angle in a semicircle. Okay? Or if you want to say it in a different way, you can say chord BD subtends an angle of 90 degrees at the what? Circumference. But this is the best way of writing it. But if you say chord BD subtends an angle of 90 degrees at the circumference, therefore BD is a what? It's a diameter. Okay? Or you can say line subtends 90 degree angle. Then you specify that at the circumference. Then it will also be acceptable. But this is the reason which I would suggest you write whenever you are asked to prove that a line is a diameter. Okay? Whenever you are asked to prove that a line is a diameter, you use that one. All right? Any question? Any question? All right. Don't have a question, then let's move on to this one. All right. Now, with this question, first you're supposed to answer 11.1, which is just a completion of a statement. Opposite angles of a cyclic quad are what? They are supplementary. Or you can say add up to what? 180 degrees. So the opposite angles of a cyclic quad are supplementary, or you can say they add up to 180 degrees. All right, let's come to this question now. The answering of this one. Now, the first part of the question says, show that MC is equal to MD, and it's 5 marks there, right? Which means the question requires you to write some statements and reasons until you come up to the conclusion that MC is equal to MD, right? So, I'm not sure how you did it, but this is how you're supposed to do the question. So first, just to remind you, please buy highlighters before your June examination. You need to buy some highlighters to help you to add some stuff there. Okay? So MC is this line. And then MD is that line. Now I just need to add on the diagram that AB is parallel to CD. We are given that here. Okay? AB is parallel to DC. So it was better here to add that on the diagram, because unfortunately this diagram did not indicate that those two lines are parallel, but it was written in the sentence there at the beginning of the question. Okay, now if you want to prove that two lines are equal or two sides of a triangle are equal, you have to prove that these two angles, this angle and that angle, are equal first. I'm going to repeat that and make sure you pay attention. if you want to prove that MC is equal to MD, these are two sides of a triangle. You have to prove that the angles that are opposite those two sides are equal. Okay? That's where you start. Okay? So, for this question, we don't have a tangent yet. Please be aware of that. There is no tangent. So first, I'm going to say angle D3 is equal to angle A. Okay? So, we are answering 11.2.1. So, 11.2.1. So, I'm going to say D3 is equal to angle A. And my reason there will be corresponding angles. Remember, if you write that angles are corresponding, you have to state the lines that are parallel. Okay? So that will be AB is parallel to CD or DC. Okay? So these two angles are equal. Then I also need to prove that, remember, the objective is to prove that C2 is equal to D3. Right? Now, if you look carefully at the diagram, we have got this cyclic quad. It's A, B, C, D. That's a cyclic quad. And C2 is an exterior angle of a cyclic quad. Okay, so C2, which is this one here, it's an exterior angle of cyclic quad, so it's equal to angle A. Okay? So, I'm going to write it here and say C2 is equal to angle A, and my reason will be exterior angle of the cyclic quad. How many of you saw that when you were doing the question? How many of you saw that? Huh?
I did, but I still got a 0, so it doesn't matter.
Right. Now, once you get to this point where you have the same angle, yes, you got the, you know why you got that. All right. Those two statements have got a common angle, which is angle what? A. Because of that, I can now conclude that therefore, angle C2 is equal to angle D3, right? I don't have to give a reason, it's a conclusion. Okay? There is no really need to give a reason there. It's just a what? A conclusion. Right?
We have done the same thing with angle B.
Yes. So if you also wanted to do it, you could have done it with what? By proving that D3 is equal to angle B and angle B is equal to angle C2. So this question could be done in two ways. Are you following that? D3 is an exterior angle of a side of the cyclic quad. So it's equal to angle B. Angle B is equal to angle what? C2. So you could also prove this by using angle B. So you had two ways to prove that those two angles are equal. Okay? Once you prove that these two angles are equal, you are done with the question. So we now carry on here and then say, therefore, MC is equal to MG. And you have to give a reason now. The reason is sides opposite equal angles. It's not angles opposite equal sides. Okay, look here. If you prove that angles are equal based on sides that are opposite them that are equal, that's when you say angles opposite equal sides. But if you are proving that two sides are equal using angles, your reason will be sides opposite equal angles. You didn't know that. Are you serious? Yes. So you skip grade 8, grade 9, grade 10, you've never heard about that. Okay, look here. Yes. No. Alright. Can you go back to your reasons? Go back to your reasons. Go back to your reasons. Hey, can you go to your reasons? I taught you this, all of you here. Yes, when you're in grade 10. Alright. If you go under triangles, please go under triangle. Under triangle. Right? If you go to statement number 3 and the reason says the angles opposite the equal sides in an isosceles triangle are equal. Then the reason is angles opposite equal sides. Then the fourth one says the sides opposite equal angles in an isosceles triangle are equal, which is the case we have here. It's the sides of the what? Triangle that are equal. And how do you write the reason? It's sides opposite equal angles.
So will you give ground to
What?
you give ground to opposite equal sides?
Yes. It's not the same. It's sides opposite equal angles. Okay, it's 5 marks. It's not the same. There is a difference when you are proving that the angles are equal because the sides opposite them are equal, and proving that the sides are equal because the angles opposite them are equal. There is a difference. Okay. Can you pay attention, please? All right. In terms of mark allocation, this is how I would allocate the marks. 5 marks there. Okay. So obviously, I'll give a mark for that reason. Okay. I'll give a mark for that. Then I'll give a mark for. Okay. Here, I'll give for statement and reason. Statement and reason. Well, I might not give a mark for deducing that C2 is equal to D3 based on those 5 marks. So I would allocate it like this. Okay, because this is obvious. If you get those 2, this is obvious. Okay? Are you following that? So I would allocate it that way. Alright. Any question? Any question? Right, let's move on to the next one. Now the next one says if D3 is X, so this angle there is X. Okay, so D3 is X, determine the value of M in terms of X. Okay, now this is very interesting. Once you do the first part of the question, some of the information we have in 11.2.1, we need that information to carry on to do 11.22. All geometry questions have a connection. They are not in isolation. So if you see a question like this 11.22, after having done 11.2.1, be aware that some of the information here in 11.2.1, you might need it to do 11.22 and 11.23. Geometry questions are not in isolation. Okay? They are connected. So, I would suggest here, yes?
Can you get the first question?
Well, okay. I would say you might have challenges if you don't prove that C2 is also equal to D3. Right? If you manage to prove that C2 is equal to D3, then I can assure you that 11.22 will be easy to do. But if you didn't prove that D3 is equal to C2, you have problems with 11.22. Because those two questions have a what? A connection. So this angle is X. Okay? We have proved that already. Right? So you add it on your diagram. That's why I said we have to provide you with a diagram sheet, okay, where you write your stuff in there. I wish you would see my. All right. Okay, so let's carry on. Now, who can tell me how to calculate m based on that?
M
It will be 180 minus what? 2x. So it's gonna be easy now to do 11.22. So if you're answering 11.22, okay, if you are in my class, first thing you identify the triangle that you are going to use in order to determine the value of m. So in triangle CDM, okay, in triangle CDM, angle C2 plus G3 plus angle M is equal to 180 degrees. And your reason there, sum of angles in a triangle. Okay? But we already know that C2 and D3, they are both equal to x. So I can write here x plus M, that's equal to 180 degrees. Okay, allow me to get onto the top there. So from here, you can end up having angle M is equal to 180 minus 2x. Okay, so this angle, okay, let me move on to the next diagram. So this angle is x, that's 180 minus 2x. This is x. Okay, this is also x. Okay? Alright? So we have got 4 angles that are each equal to x. Let's move on to 11.2.3. Now, 11.2.3, it says hence. Now, what does this word hence mean in maths? Yes.
The question at the top. So
Yeah. So you use the information from questions at the beginning of the questions. Okay? This word here, it's like a hint that you are being given. That it's a hint. Okay? Use the information from the previous question. Alright. Now, if you want to prove that BODM is a cyclic quad, okay, highlight it first so that you can see if there's a butterfly. In this case, there is no butterfly. So let's identify. So it's BODM. So that's the quadrilateral. You're supposed to prove that that quad is cyclic. By cyclic, it means we can draw a circle, okay, such that the circumference passes through B, O, D, and M. It's just a quadrilateral, which is not inside the circle. But we need to prove that it can be inserted in a circle and its vertices will be at the circumference. I'm giving you an opportunity to digest. So, which of the two methods would you use there to prove that the quadrilateral is cyclic? Huh? Because there is no butterfly, so you throw that out. You are left with what? Opposite angles are supplementary, or you identify an exterior what? Angle.
you can use exterior angle.
Did you do? Okay. All right. So, in my case, I'm going to prove that angle M is equal to angle O1. Can you pay attention? In my case, I don't know how you might have done it, but I'm going to prove that angle M is equal to O1. Okay? That's what came into my mind, and that's what I'm going to do. Okay? Right? Because it's actually the easiest way to do it. Right? Because it's a challenge to prove, to determine the size of that angle D1. To calculate D1, it's a challenge. Okay? To calculate D1 is a challenge. because this shape here, A, B, or D, is not a triangle, it's a quad, but it's a weird quad. So to calculate D1 in terms of X, it's not that simple. So I'm just gonna prove that angle O1 is equal to 180 minus what? 2x. Okay?
Yes.
Sorry, not 180, but I'm gonna prove that if you add O1 to angle M, you get 180. That's all. Yes.
So is O1 in the center of the circle?
Yes.
So it means
Angle center
yeah,
equal to 2
the angle at the it's 2 times the angle at the circumference.
To find which angle?
Angle 1. So it's 8. Yeah, 2.
Okay. Right.
This is still correct.
Look here. Be very careful. If you want to find O1, which angle do you want to use to find O1?
8.
Angle what? Okay, you want to find angle what?
Use 8.
Angle 8, yes.
This is still correct.
Okay, yes. Hey, can you pay attention? Can you pay attention? So, as I said, the easiest way is to calculate O1 first. If you add O1 to angle M, you must get what? 180. Are you following that?
Yes.
Right? So, first, be aware that there is an invisible chord here. That's the invisible chord. And that chord, it subtends angle A at the circumference. It also subtends angle O1 at the center. So, to answer that one, so we say O1 is equal to 2 times angle A, and the reason here we say angle at center is equal to 2 times angle at circumference. So O1 will be equal to 2x. Okay? We are not done. Then we carry on and then say angle O1 plus angle M must give us 180 degrees. Now, in this case, you can't give your reason as opposite angles of a cyclic quad because you are asked to prove that the quadrilateral is what? Cyclic. Do you hear me there? You can't give the reason here as opposite angles of a cyclic quad. If you do that, means you are saying already the quadrilateral is what? Cyclic. It's not cyclic until you prove that it's what? Cyclic. Are you following that? No, you don't give it. You just write that statement. Now, let's see if whatever is on the left is going to be equivalent to what's on the what?
The right.
On the right. So O1 is what? 2x. Angle M, 180 degrees minus 2x. Okay? Then we simplify the left-hand side. Obviously, I'm sure you can all see. Hey, can you pay attention? Stop looking down. So these two here, they will cancel out. You'll be left with 180 degrees is equal to 180 degrees. Then you can say, therefore, BOGM is a cyclic quad. Right? Your reason, converse opposite angles of cyclic quad. Okay, and then you are done. Okay. Alright, is there anybody who has got a question so far up to here? Any question?
Ask you questions.
Okay. Alright, so this question requires us to prove that angle B1 is equal to angle T3. So you take your highlighter, okay? You need to to visualize the angle. When you're answering the geometry questions, don't just look at the question. Understand your diagram. Okay? Know your diagram. To get the solution, it has to do with understanding your diagram. Okay? So B1, it's here. That's B1. Right? T3 is this angle. Alright? Now, always, when you are given tangents, you see in this question we have two tangents, EB and EC. Okay? I'm going to highlight the tangents. Whenever you see a tangent, the first theorem which must come into your head is the tan-chord theorem. Remember, there are three tangent theorems. Among the three, the most common one is the tan-chord theorem. And most questions on tangents, you have to use it. So, we have got BE, that's a tangent, right? And then we have got CE, that's also a tangent. And the two tangents, I'm sure you can see there, we have got theorem what? 8. They are drawn from the same what? Point outside the circle. Okay? Which means for this question, we are going to use theorem 8 somewhere. And we are also going to use the tan-chord theorem as well. Right? We may also need to use theorem 7, tan perpendicular to radius, because, okay, no, sorry, there's no center, so T is not a center, so it's only theorem 8 and 9 that we have to use. Tans from a common point and the tan-chord theorem. Right? Now, also, the other thing, we are given two lines that are parallel. Okay? So we are told here that TE is parallel to AC. Okay? TE is parallel to AC. Again, whenever you see lines that are parallel, identify alternate angles, corresponding angles, co-interior angles. Every time you see on a diagram lines that are parallel, you are going back to grade 8 when you did geometry of what? Straight lines. Don't be scared because you saw the diagram. Okay? Don't be scared because you saw the diagram. Right? As I acquire more experience in terms of this, I'm realizing that geometry is not that difficult. Okay? It's not. Understand your diagram. Know where to start. Do you know your theorems? Are you aware that your theorems are classified into 3 groups? Center theorems, cyclic quads, and tangents. Okay? And don't surround yourself with people who are negative about geometry. If you hear someone who is negative, tell that Mr. Chiponda said geometry is easy and I'm going to believe it. Because I'm proving you now. Okay? Alright, so let's prove that B1 is equal to T3. Okay? Now, sometimes if you want to prove that two angles are equal, like in this case here, there is no angle given. Do you see that? There is no angle given. Now, what that means is you might need to introduce your own variable. So you can say let x be equal to a specific angle. And then you can carry on from there. Okay? So, for me, I'm going to say let x be angle B1. Okay? You can choose any other angle you want, but it will be your choice. Okay? As long as whatever angle you identify is going to help you to solve the what? The question. Okay? Are you following that? Right? So, we have a tangent, right? This is B1. And we have this chord here. Make sure you look, because geometry is about understanding your diagram. So, we have this chord BC. Can you stop talking and pay attention? That's our chord what? BC. The angle between this chord BC and the tangent BE is B1. And the chord BC subtends angle A at the circumference. So what that means is this is also what? that will become x based on Tan-Code theorem. Right? According to the Tan-Code theorem, you must have a tangent, then the tangent must come into contact with the chord, and the two must form an angle. The chord itself must subtend an angle at the circumference. And this angle here will be equal to A1. That's the Tan-Code theorem. The angle between a tangent and a chord at the point of contact is equal to the angle in the alternate segment, which we just abbreviate as the Tan-Code theorem.
You have to add add your own variables for the variables.
For this question, if you want to do it for this question, you have to do that. Because there are no given angles. I'm sure you saw that in the previous question, this one is, you only do it if there are no angles provided. Because don't expect to get a question with given angles. Sometimes we have a case like that. Here, they told us to read the question, and the question specifies that D3 is what? Is X. That's why we worked out with D3 being X. Now, sometimes you can get a diagram where to solve the problem, you might have to introduce your own what? Your own variable. Are you following? Yeah, geometry stretches your ability to think. That's the purpose. That's why it was introduced into the mainstream curriculum. Before 2014, it was not part of the curriculum. It was easy to pass messages. Trig has always been in the curriculum. Okay, all right. So already I'm smiling because I can prove that those two angles are equal. Right, so we are doing 11.1. Okay, let me do it there. So first, I'll say let angle B1 be X. Okay, then angle B1 will be equal to angle A. They are both equal to X, and that's Tan-Code theorem. Okay? All right? And then angle T3 is corresponding to angle A. They are corresponding angles because TE is parallel to AC. Therefore, T3 is corresponding to angle A. So I'm going to write here angle T3 is equal to angle A. They are both equal to X. My recent corresponding angles. And then we state the lines that are parallel. So that TE is parallel to AC. Okay, so I'm smiling already. Right? I'm sure you can see that we have got a common angle in both equations or statements. What that means is, it therefore means that angle B1 is equal to angle T3. Okay? Are you following? On last week on Friday, if you struggle to answer this question, and don't worry, right? The purpose was to wake you up, okay? We'll wake you up so that you don't take things lightly, right? If you got a 0, it's fine. What's important for me is that I hope you are getting it now. Okay, I hope so. And you also have to practice. By the way, but that's up to you. All right, let me carry on.
When doing Tan-Code theorem, your time triangle have to touch the other, the circumference of the circle.
Yes.
Oh, that's what
Yes. Every triangle, right? We are coming to something very important, right? Every triangle has vertices that are concyclic. Okay? What that means is the vertices of the triangle, they will be on the what? Circumference. So you can draw a circle passing through the three vertices of any triangle.
Why can't you say A that B1 is T3
Because we don't have a triangle. We don't have a triangle. You see,
Yeah, but
it stops here, right? No, it goes up, but this vertex here is not at the circumference. Yeah. All three, and also this vertex here is not at the circumference. So yes, yeah. So you have two vertices that are not what? At the circumference.
always have to be.
Yes, they always have to be. Yes, all three.
So if you drew your own circle,
Okay, generally, you don't have to go as far as solving the problem by construction. Like, if you are to go as far as trying to prove that V1 is equal to T3, and then you say, then you might have to prove that BT is a tangent to what? It's a tangent to circle which passes through BT and F, which will be very complex to do. Okay. Right. But we can, okay, if you want to create our own question there, okay, we can create it, but I don't want to go as far as that because we have already told that BE is a tangent. So there's no need to prove that it's a tangent. Alright, anyway, is there anybody who has got another question before I move on? Right, so let's move on to the next one. That one there. We need to prove that, pay attention, we need to prove that TBEC is a cyclic quad. Okay? TBEC is a cyclic quad. So what you do, you go to your diagram, highlight it, okay? Highlight the quad. So we have got TBEC, which is this one here. That's the quad. So we need to prove that that quad is what? Is cyclic. Do you see any butterfly inside that quad? Huh? Okay, there is a butterfly. So the butterfly is this one here. I need to draw it properly. So we've got that one.
so you can watch this in the
No, you don't have to connect. There is no need to connect. You just want to identify that butterfly. Okay, so what this means is, can you pay attention? For this question here, I'm going to try and solve it using the converse of theorem 4, which is angles in the what? Same segment. Right? So let me label my angles. So I know that this is X. Okay, I have already done so. This is also what? X, and this is X. Right? Then the next thing now, if I'm to prove here that this is a cyclic quad, all I have to do is prove that C3 is X. Okay? I just have to prove that C3 is equal to X. And that's easy to do for this question. Okay? So, we are doing that one. So first thing, I'm going to write here that BE is equal to CE. And these are turns from a common point. Okay? They are tangents from a what? A common point. Now, because of this, it means angle B1 has to be equal to angle C3. Okay? So here I can then say therefore B1 is equal to C3, they are both equal to X, and my reason will be, now here I'm proving that the angles are equal. Can you pay attention? I'm proving that the angles are equal based on two sides that are equal, that are opposite angles. So my reason here, it will be angles opposite equal sides. Okay? So from here I can, well, I'm almost spoiled for choice. So what this means is, but, right? We already know that B1 is equal to T3, and they are both equal to X. Now this has been proved already. So proved in what? 11.1. Therefore T3 is equal to C3, and they are both equal to X. Therefore, now I'm just going to conclude now. Indeed, this quadrilateral is cyclic. So I'll say TBEC is a cyclic chord. And my reason, it will be converse. Okay? Converse angles in the same segment. Okay, yes.
What if you said C3 is equal to A, 10 cos 0, and then C3 is equal to A? The same way we said
Okay, yeah, you could also go via that way as well. So you could say C3 is equal to angle A, right? Then you connect obviously A and T3, then from there T3 to what? To C3. That's fine as well. Okay. Okay. So the question could be done in two ways. Are you following that? Right? C3 is an angle between tangent CE and chord BC. BC subtends angle A and the circumference. Therefore, C3 is equal to angle what? A. Also, because we already proved that B1 is equal to C3 and B1 is equal to A is equal to X, so those angles are connected. They are all equal to X. Angle A, T3, B1, and C3. Okay, so you are spoiled for choice there because you've got two ways of carrying on. Okay? I hope you are getting it. Alright? Can I carry on?
Yes.
Huh? So let's move on to 11.3. Now, 11.3, we need to prove that ET, this line here, bisects angle BTC. So BTC is this angle. So now if you want to prove that TE bisects angle BTC, we just have to prove that T2 is X. Okay? Right? So it's not that complicated, and it's 2 marks, which means you can do it as easily as possible.
Yes.
Right? You can do it as easily as possible. Now, I'm sure you can agree with me that T2 is going to be equal to B1. We have already proved that TBEC is a cyclic chord. Okay? So what that means is I can write the angles in the what? Same segment. Because we proved that TBEC is a cyclic chord. Are you following that? Okay? Now I want to do something interesting now. So what that means is I can draw a circle. Okay, let's see if I can put the circle and make sure that it passes through those three. So, fortunately, we have got technology. So we have got a scenario like that. So the TB then okay. Okay, so that's what we are talking about. When we say, can you pay attention? When we say TBEC is cyclic, what that means is point T, point B, point E, and point C, they will be on the circumference. Right? The circle is invisible. I've added it there. It's invisible. But it can be what? Drawn. Okay? Huh? So, we are done with that question. Let me just write it properly. So, to prove this, we are going to say T2 is equal to B1. They are both equal to X. And our reason here will be angles in the same segment. Okay? Then we say, therefore, T2 is also equal to T3, and they are both equal to X. Right? Then we write our final conclusion and say, therefore, ET bisects angle BTC. Please, you can only say you have answered the question if you prove that T2 is equal to T3. If you haven't proved that T2 is equal to T3, then you haven't answered the question. Okay? Because the question says, prove that ET bisects BTC. So if TE is a bisector of BTC, means it divides the angle into two equal what? Angles. So you have to prove that T2 is equal to T3. So I have proved here that T2 is X, and we already know that T3 is also X. Therefore, those two angles are equal, hence TE is a bisector of angle BTC.